The rock beneath you is slick with salt. Cold water rushes in, then recedes, dragging pebbles and shells with a rasping grind. In the darkness, something moves sideways, quick, intentional, its shell clicking softly as it slips into a narrow crack in the stone. This is a body plan that shouldn't exist. Not once, not twice, but again and again over millions of years. Creatures separated by vast evolutionary distances, some once shaped like lobsters, others more like shrimp, keep converging on this same form. Flattened bodies, armored shells, claws that function like mechanical tools, legs that move sideways as though the rules of motion themselves have been rewritten. Evolution keeps making crabs. And here's the tension. Natural selection has no foresight. It doesn't plan ahead. It doesn't recycle ideas because they're good. So why does life, time after time, fall into the exact same solution? Is it coincidence, constraint, or a glimpse of just how limited and how powerful evolution truly is? By the end of this video, we'll answer a deceptively simple question that cracked my brain the first time I encountered it. Why does evolution keep making crabs? At first glance, a crab is simply a crab. 10 legs, 2 claws, a rigid shell, eyes perched on stalks, a sideways shuffle. You've seen one on the shore, on a dinner plate, or behind glass in an aquarium. But while researching this, I ran into a detail that stopped me in my tracks. Not everything we call a crab is actually a crab. In fact, many so-called crabs aren't even close relatives. King crabs? Not true crabs. Porcelain crabs? Not true crabs either. Even hermit crabs belong to a completely different branch of the evolutionary tree. And yet, they all arrive at the same form, the same structure, the same unmistakable outline. Biologists have a name for this pattern: carcinization. It refers to the evolutionary process in which a crustacean evolves into a crab-like body plan. And this has happened at least 5 separate times, possibly more. To grasp the scale of that, imagine evolution as a blind sculptor chiseling away without any idea of the final figure. Now imagine that sculptor starting with different blocks of clay, but carving the exact same statue again and again. Why does this matter? Because it undermines one of our most comforting beliefs about life on Earth, that evolution is endlessly inventive, infinitely adaptable, overflowing with strange possibilities. But what if it isn't? What if, under enough pressure, life is forced into only a handful of stable solutions? And if that's the case, what does it imply about life elsewhere in the universe? To understand why evolution keeps producing crabs, we have to roll the clock back. Roughly 500 million years ago, the oceans were teeming with early arthropods, animals with segmented bodies and jointed limbs. From one of these lineages emerged crustaceans, shrimp-like creatures with elongated bodies, long tails, and flexible segments. This stretched-out body plan is known as macrorin. Think shrimp or lobster. Crabs, however, belong to a different category: brachyurin, short, compact bodies with the abdomen tucked beneath the torso. Here's where it gets strange. Crabs didn't originate from a single crab ancestor that simply branched out over time. Instead, multiple macrorin ancestors, long, narrow, tail-dragging animals, independently collapsed into the crab shape. Their bodies shortened, their tails folded underneath, their shells broadened, their armor thickened, again and again and again. Why? The first hint comes from physics. A crab's body is squat and close to the ground, which lowers its center of gravity, like a race car hugging the asphalt. Compared to a lobster, a crab is more difficult to flip over, harder to seize, and tougher to crush. Think of it this way. A lobster's exposed tail is like leaving the engine block hanging outside the car. A crab pulls everything inward, sealing itself up like a tank closing its hatches. That alone offers a huge survival advantage. And yet, that's not even the strangest part. Here's what caught me off guard when I really started digging into this. A crab's body isn't just compact, it's modular armor. Each plate overlaps like medieval plate mail. The joints are reinforced. The most vulnerable organs are buried deep inside. Pound for pound, a crab's exoskeleton provides a level of protection that would require far more material in a long-bodied creature. Think about scale for a moment. If you spread the same amount of shell over a lobster-shaped body, it's like stretching armor across a longer wall. Crabs concentrate it where it matters most, Predators notice the difference immediately. Fish can swallow shrimp whole. Octopuses can rip lobsters apart. But crabs make predators earn it. And natural selection favors anything that boosts survival by even a small margin. Over millions of years, that pressure compounds. So evolution leans in one direction, shorter, tougher, broader. But the mystery runs deeper. Why claws? Claws aren't just weapons. They're tools. A crab can crush shells, tear flesh, dig burrows, battle rivals, signal to mates, and manipulate objects, all with the same pair of appendages. Here's the detail about claws that completely blew my mind. They're asymmetrical by design. In many species, one claw evolves into a crusher, the other into a cutter, like having a hammer and a knife permanently fused to your body. Consider the scale. Some crab claws generate forces comparable to industrial bolt cutters. Relative to body size, they rank among the strongest grips in the entire animal kingdom. That kind of versatility opens doors. Crabs can tap into food sources other animals simply can't reach. Hard-shelled mollusks, buried prey, tough plant material. And once a lineage starts down that path, stronger front limbs, heavier armor, a compact frame, it's effectively a one-way street. But evolution should still have choices, right? So why does it keep picking this one? That sideways walk looks awkward to us. It isn't. Crab legs are set laterally, like a suspension bridge rotated onto its side. This gives them exceptional sideways stability and explosive acceleration. A crab doesn't have to turn its body to escape danger. It can launch itself instantly in any direction along the ground. Picture this, a car that never needs to steer, only slide perfectly sideways at full speed. In tight spaces, reefs, rocks, narrow crevices, that ability is everything. This body plan thrives in complex terrain. And Earth's coastlines, they're among the most intricate environments on the planet. Which brings us to the next realization. Crabs didn't just dominate the oceans. They moved onto land. They climbed trees. They spread into freshwater. Some even inhabit depths thousands of meters below the surface, enduring pressures that would crush a submarine. Consider the scale. The coconut crab can reach nearly 4 kilograms, roughly the size of a house cat, and still climbs trees using essentially the same body plan as a tide pool crab no bigger than a coin. That level of adaptability is staggering. When environments shift, and they always do, generalists are the ones that endure. Crabs can eat almost anything, live almost anywhere, defend themselves effectively, reproduce efficiently. Once evolution stumbles upon this design, it's incredibly hard to surpass, and that's the unsettling truth. So what does all of this point to? It suggests that evolution isn't an endless playground of shapes, it's a landscape with peaks and valleys. Some forms are simply more stable, more efficient, more likely to survive. Crabs occupy one of those peaks. When different evolutionary paths roll downhill under similar pressures, they tend to settle into the same valleys. And this pattern isn't limited to crabs. Eyes have evolved independently at least 40 times. Wings emerge separately in insects, birds, and bats. Streamlined bodies keep reappearing in sharks, dolphins, and ichthyosaurs. Same challenges, same answers, which leads to a question that's both chilling and exhilarating. If life exists elsewhere in the universe, on ocean worlds, on planets shaped by gravity, predators, and competition, would alien seas be filled with something crab-like? Not crabs as we know them, but armored, sideways moving tool-using generalists. The crab might not be an accident. It might be a destination. Back on that cold, dark shoreline, the crab slips away into the rocks. It doesn't seem remarkable, yet it stands for something profound. A reminder that evolution is both inventive and limited, wild and predictable, chaotic and unsettlingly repetitive. This realization hit me hard the first time it sank in. Out of millions of possible shapes, life keeps looping back to the same solution. Not because it's flawless, but because, under pressure, it works. And somewhere on a distant ocean world beneath an alien sky, something may already be skittering sideways into the darkness. Not because it chose to, but because evolution did.